Okay. Yeah, sure. Go ahead.
So in this question is of linked list. So you are going to get a linked list.
Mm-hmm.
Yes. And linked list is going to have odd element and even element.
Mm-hmm.
So the thing is you should keep odd element at first, like arrange the linked list in such a way. All the odd element are at first and all the even element are at last. Let me show an example. So suppose this is a linked list. So like in here, odd element are 1, 3, and 5. So your output should be like 1, 3, 5.
Mm-hmm.
These are all the odd elements. After that, it should be even elements. 2,
Mm-hmm.
4, no. So this is the output. This is the question.
Okay. Um. So we have linked and linked list. The value of them is only numbers. Yes.
Exactly. Yes.
Are they sorted?
Not exactly, but it doesn't matter. Just odd element like, sorry, I forgot to clarify one thing. Odd element as an index, not the actual value, if you know what I mean.
Uh-huh. Got it. So the sorting doesn't really matter, as the values
Yes.
doesn't really matter. Okay.
Yes, it's just the index. So it can be like something like 3 or 4 back here. Is still odd number is 4, 3, and 5.
Mm-hmm.
Don't value don't matter. Yeah.
Okay. Um. So when we're thinking of linked lists. Okay. So we're thinking of linked lists. Let's start with the basics here. So brute force solution is kind of traverse through the entire traverse through the entire uh, linked list and assign entire linked list for. Okay, what's the output? Should be a linked list as well, right?
Yes.
Okay,
Yes.
so traverse through the linked list and assign, let's say, assign a new linked list for odd and linked list for another linked list for even, and then we merge them together. And
Okay.
okay, so but this solution would cause like for time complexity is going to be linear. This is like
Of
for the time.
endless space complexity.
Yeah, for space complexities is also O of n. Yeah, as you said. Um,
Yes.
is this like the solution that we could go for, or we can improve upon that?
Like a brute force is kinda easy. So we are looking for O of one space complexity.
Okay. So as you say,
Yeah.
we
Can
will.
we do better?
Yeah. So let's say we want to do the modification of the array in place, not in the array, sorry,
Yeah.
modification of the um, linked list. So as we are
Thank you.
thinking of the linked list, um, I'm thinking of Okay, so can we compensate? Can we sacrifice space, time complexity to add space, to remove space?
I don't think so.
Okay,
Uh, so you should try to do it in a single pass. That's the optimal solution I'm looking for. Single pass, sorry.
one pass, yeah.
Pass, yeah.
Uh-huh. Okay.
So you can make use like of some 2 pointers, maybe.
Mm-hmm.
It's like
Yeah.
to a solution. Yeah.
Yeah. Yeah, sure. So let's take an example here and kind of I have an algorithm in mind. I forgot actually the name of the algorithm, but I'll try to remember it as I'm explaining it. So if we start like pointer one, P is pointer one, and let's create another pointer, Q, P and Q. Okay. So if P and Q are pointing at, for example, they're initially pointing at the same node, but what if I made Q is a little bit to one step ahead, let's say here.
Uh-huh.
So B will point at B for example, at the current node, but Q will point at 2 first ahead. At this point, we know that B and Q are okay. So if we're talking about the index here, this is 0 and this is 1, and this is 2. So we know that B and Q are both even in terms of the
They are actually counting starts with 1,
okay.
2, and
Yeah.
not like array.
Okay. That makes it more efficient to do. Okay, so if we made B and Q, Q is one step ahead, and as we move each time, we move one step. Q is also moving one step ahead, and each time we would like to say, okay. So I'm thinking right now. So the goal is, okay. Let's say we're gonna remove B and Q here because we want to make it because this is like already a solution. We want to make it remove the solution here. I'm gonna make it 1, 2, 3, 4, 5. Let's say 6 here. Okay. Let's start from the beginning here. What we would like to do is, as we move here, for example, we start at the index of 1. We would like to make a queue, shift a queue, and put it here as an instance of the value of the queue, the value that pointing at Q. Okay. But also we would like to remove that. So as we move, we have two operations. Okay. So first thing first, we need to know where is the last value. So we need a kind of iterator. We need to, before we start the algorithm, we need another first pass to know where is the null value. For example, this is like the last element. We want to save that, like last element. It's like we want to save the value of the last element in order to access it, and in a way that we're gonna point at it. So last.next will equal the Q as a say. We're instead of null.
Alright.
Okay.
So you are like keeping track of header or start of the queue. Okay.
Okay. The last value of the Q, which is, for example, in this case 6. It doesn't really
Makes
matter.
sense.
Okay. So the first thing what we'll have is, as we move, we want to do two things. We want to make last.next is equal Q, and now we would like make B, which is the current value, B dot next is equal to Q. And we want to advance Q to be Q dot next, let's say. And there's one issue here, because we also want to advance B equal B dot next. Keep in mind that initially Q is Q is, let's say, current dot next. It's like this is like what we agreed on, and B is equal, let's say, current dot next only, or current directly. Let's call it head, because this is like initially this is like how it goes. But I'm not sure if it should be. Okay, so let's say
Or for easy sake, this is right. You can do something like just one step ahead.
just
Yes.
yeah.
And you can point the next of P to the next of Q.
Yes, exactly. So this way we'll
And
say.
then you can like advance the P, something like this. So next time, like in this example, P next will point to something like 3. It will point here. It does. And P does equal to P does next is going to bring the P to back here. Similarly, you can repeat again. You can point Q next to the P next, something like this, and you can move Q something back here.
So in the sense that, for example, we're jumping B ahead of Q, then we saying Q is B dot next.
Yeah, just like we are using simply we are using two pointer.
Mm-hmm.
So sometime Q will be in front, and in next cycle P will be in the front.
Mm-hmm. Yeah, it makes sense. And
Ah, yeah,
so then we say Q is B dot next.
yeah, exactly. Q dot next, not Q exactly. Q dot next. Remember, like if Q is only one step ahead, so like P dot next equal to Q dot next. See, P is pointing to P next is pointing to 3. This is our R1, call it something like R,
Uh-huh.
call it even. And this, let's try this and this should work. Yeah, just a hint.
Okay. So now we're keeping track of the values and we're modifying the array. And what's last is, as we said in the first time, we're declaring the last, and we're keeping track of the last here. And this is not a good way of representing them. Okay. And okay, we have now the last. Why we'll do the last is dot next is equal next as a way that we're going to link the values.
At the end, yeah. After you are done, like next step also point to the start of the event.
Hmm. Yeah. So before we start, before we modify next, we want to save the value. This is like something initial.
At the very start, yes.
Yes. So this is like how we're going to do that, and all of that we're going to be while, let's say, while b is not null and while q dot next, let's say. But q is not next. So while being q, and the last thing is
Are you sure it will work?
not.
Well, exactly. This is think about something like this example.
Okay.
So initially P is going to be here, Q is going to be here.
Mm-hmm.
So like if Q doesn't have any next element, your program is going to crash. You follow what I mean? Like in this, like you are pointing P next
Yeah.
to the next.
So we can say b dot next.
It shall be Q that next maybe.
Uh-huh.
Yes. In this program, it will crash like lots of edge cases, and it will be hard to manage them.
So here we
Yeah.
need to b, not, I mean, sorry, while b and q dot next.
It should be just Q. Yeah.
Q.
We will run to an example, but
I'm
yes.
not sure why it's q here, because we also wanted to keep track of p. So if we start with b
Yeah.
here.
But like most of the time, Q is going to be ahead.
Hmm.
Yeah, like in a single for loop, you are going to like swap P position of P, and then again you are going to swap Q in the front,
Mm-hmm.
like in a single for loop. So at the end, like after you reach the end of while loop, Q is going to be ahead than the P, in front of the P, always.
Mm-hmm. Yeah, it makes sense. Yeah, it makes sense. So in terms of the space, let's say the complexity analysis here. So for time, we already know that it's going to be linear time. But let's have a
Yes.
look here. Is it going to be linear? So let's define n. What's n? N is the size of the linked list, or let's say the length. Okay, length of the linked list. How many depth of that? For the space complexity, and this is like in our favor, because we're going to have constant time complexity, big of n.
Yes.
Okay. Um, does this solution make sense?
Yes.
Okay.
Let's start.
Yeah,
You are
sure.
already in minutes, so yeah, you have 15 minutes to code.
Okay. Um, so let's remove some of the code snippet here. Okay. So if we start by I'm gonna align that so can we use them. So if we say diff, okay, what's the name of the function?
Uh,
Find.
let's use a better name, something like even and odd. It will be easy.
What's q here?
I think it's even. Like first element is odd, second element is even. So yeah,
Okay, yeah. So here we would like to have odd. And
I think it will be even.
yeah, yes,
First element is odd.
we can have even and odd. So what we're expecting here, let's say
Something you can call it something like let me think. Odd
list,
even list. Odd even list.
even list. Okay, yeah. And now as we moving here, so we would like to have while loop to find the last. Okay, so while let's say we want to
I
have
think like you will find the last after the end of this. You don't need to do another while loop.
okay.
At the end, like odd will be. I think odd is going to be the last element,
Hmm.
and you can like point the next of odd to the head start of the even. As you can see, like in this example,
Can I can we
like
can we take an example here? Okay.
yeah, in this example, like I think odd is going to be
Uh-huh.
the end of five, and even is going to be something like null or something. So you need to point odd to the start of the even.
Mhm. Okay, which is it has been done here. Odd to start with the even, but even will be, but this is like sorted value. This is like already sorted. We cannot do that. This is like is not a good example. I don't think it's a good example.
I don't think sort matters.
I mean now this linked list has been already processed because all the
Yeah.
odd are on the right side. We need another example. For example, this example here.
Yes, makes sense. Yeah.
Okay. So what do you mean here by odd? Can you because even is even start could be starting from here, and because we can start a e and o. Because what I'm saying is we need to identify because once we start even here it should be at the last. So we would like to link to, but in the beginning we don't have reference to the last element, which is here. That's
But
why.
even is going to be at the end something like 2, 4, 5, and last of even is going to be 5. So but you need to point it to the start of the even, that is 2. Follow what I mean?
No, I'm not following. It's like confusing right now. So is it, okay, let's simplify it. Let's take okay. So 5 is like reversing it instead of having it um, okay. There's a missing element that I don't understand here, which is um, we can solve it the way I've said initially, which is kind of finding the last element, right?
Let's try that.
Okay, then we can improve upon that. What do you think?
Okay.
Okay. Okay, so let's find the last, even though it's gonna add a space complexity, but it's gonna say linear anyway. Um, so let's say we want the head, right? And head, uh, let's say we want a head here. And okay, so we would like to point at the head at the last. So while last we can last is equal last dot next. So what does allow us to find the last value? And exactly what we're doing here is we're making last. Okay, so instead of even, we're gonna rename it q with even here. Okay, oopsie, even, um, even here, even. odd, and lastly this one. So the even would be head.next. Yeah, okay. So we're iterating through the while loop, and we're we're making the loss of dot next equal to even. We're saying if the even, let's say, if even is the first value is 2, pointing at 2, and we're making 5, we'll point at 2. That's what we're doing here. So we're saying
Mm-hmm.
last is 5, and 5 will be pointing at even, and which means like 5 is pointing at 2. So that's what you're trying to do here. And then we're going to odd.next is equal to odd even.next, like jumping one step after the odd, and we're making even.next is equal to odd.next. Yeah, it makes sense. Does it make sense to you?
Let's run the yes. Let's run to an example.
Okay. So the last thing we're gonna do is we're going to return the head because we're modifying it. Yeah, okay. So let's run another example. Yeah, sure. Let's pick example, the first one here, and yes, right here, implemented. So what we're doing in the first thing is we're saying even, and let's say odd and last. Yeah. So the even the first part is going to be, and we have to say that head is pointing at 1, and we're saying about it in the head. Okay. Right now is we're pointing at the head, so even will be equal to, I'm referring 1 and 2 as their index. They're not at the value. So that's assuming that the value is still the same as before. Okay.
Mm-hmm.
Okay. Now the odd is 1, and loss has not been calculated yet. So the first thing we're going to do is define the loss, and we're going to iterate with the while loop, and we'll find the loss, and we find the loss is pointing at the value, which is 5, the loss element.
I
The
think it will be null if from your code.
Okay. Yeah, so instead of null here, yeah, it was null. Yeah, we should point at head, and
No, I'm just saying like after this while loop, last is going to be none. Simply.
hmm, okay. And the reason before that, because we're iterating here, let's say, because we're each time we're doing the while loop, and we're advancing. While okay, so we say while last dot next, let's say, while last dot next is not null, so we can make last is equal last dot null. Does it make sense?
Mm-hmm. It makes sense, yeah.
Okay. So now we declared last to be 5,
Five.
and
Yes.
yeah, last is now 5, and we're going to calculate even while we have even and next. Like we can enter the second while loop, and while even is not null, and even dot next not null, both of them are not null, we can go to the first condition. So last dot next is equal even. Okay, so last will be, so we'll start by pointing. Okay, I'm trying to find, yeah. So we'll point at we're, even is 2, so we'll point last dot next equal even. So 5 will point at 2, and we'll make odd dot next. So odd will be pointing at
Three.
odd dot next will be pointing at even dot next, which is 3. Yeah, and so even we would like to make it odd. Even will be equal, even dot next will equal odd dot next. So even will be uh, at this case even will be
Should
okay.
be three.
Yeah, should be
That's
4. Should be 4. Yeah.
it will be three as of your code. It should be four, yeah. But
Mm-hmm.
see next one. We just modify the odd, so odd next is pointing to 3.
Yeah.
So even next, odd dot next is just going to be 3. It's not quite gonna work. I think like you can move odd by one pointer, something like odd equal to odd dot next.
Yes. So we're saying
This time odd is going to point to us 3,
yes.
odd dot next is going to point to us 4. Yeah.
Exactly. Exactly. Yes. Yeah. Sure. Okay. So
Yeah. Oh,
okay. So we should continue now. Even is now pointing at 4, and
after that, yes, alright. It
okay.
is good so far. Yeah.
Yeah. Shall we run the test? Something like that.
And like it as what happens after this? Let's run through a whole code. What happens after this?
Okay. So what happens after that? Okay. So we're going to keep doing that until we hit the dead end, which is the condition while even and even dot not
You are
next.
just no even is always going to stay at the same place from your cursor. Even though you are like setting even
Yeah.
next to something else,
So
even
we
is in the
want
same place.
we want to yeah. So we want to make even to even dot next. We want to forward it. So this way
Alright,
we're forwarding it
let's
one step
alright.
ahead.
Let's go on the code. Let's go on the code, yeah. Let's run that. Let's go to code. So after that I think let's run through this. We have till here. So by this time even is pointing to 4, odd is pointing to 3. Yes. Let's run through code. We still need to 5. So yeah, let's try.
Okay.
What's the point of this? That's what I'm asking. We are not like modifying last two at all.
Okay. I'm trying to understand what's your point here. You're saying that there's something wrong with last dot next, as we're doing something at the end and we're doing something in the front.
Yes. I'm saying like let's run whole example. We are till this time, so yeah, let's keep on running. That's what I'm saying.
Okay. Um. Okay. One more. I mean, complete the example. This is what you're saying. Yeah. Okay.
Yes.
Yeah. Sure. So
So at first last is going to get called.
yeah. So
So last
we're
the last is at 5. So last of next is going to point to even. So it is just going to be pointing to 4 like this.
yeah, exactly. So we would like to make it forward last as well. Um. Okay. Last equal last dot next.
Let's say it's pointing to 2 and it's pointing to 4. That's what you're saying, right?
Yeah.
Something like this. All right. After that, odd dot next is going to point to even dot next. Odd next is this element, even next is 5. So yeah, so far so good. Something like 5, right?
Mm-hmm.
You are going to forward odd by 1, so odd will be forwarded.
Yes.
Even next equal to odd dot next is going to be null. Odd is at 5 and odd dot next is going to be simply null.
Mm-hmm. Mm-hmm.
Odd and is going to point to null and we exit the while loop and we forward the last by 1.
Mm-hmm.
But as of now, like odd and even are separate. As you can see, they are not connected. Like 5 should be pointing. I'm just saying like next of 5 should be pointing to 2, start of the 2. Our output was supposed to be 1, 3, 5, 2, 4, and null. I'm just saying like as of now, odd and even are separate. They are not connected.
Mm. So you're saying that okay. So that's an issue when we added the last. So we can remove the last and we can
We
modify
can do
the.
something. Let me show you. It's
Mm-hmm.
good. You can like keep track of start of the even. Even here is even.
Mm-hmm.
So even head is always going to be pointed towards 2.
Yes.
Even though one pointer even goes to null, his head is going to be just 2,
Mm-hmm.
and an odd is going to be at 5. So after this, simply you can do odd dot next is equal to even head. Simply odd is at 5. We run an example
Exactly. Yeah.
into even heads. So yeah, it's going to be connected.
Exactly. Yeah.
Exactly. Yeah. Yeah.
Yeah.
We
It
don't
make
need last.
it makes a lot of sense. Yeah. The
Yes. And this is the correct solution. It's working.
okay.
You can run through the example later on.
Yeah.
It's working.
Yeah. Sure.
As my turn.
Yeah. Okay. I'm gonna delete all of that. All right.
So how do you like this question?
I felt like when you added the last event head, even head. Uh, like I remember the exact solution that I've solved it before, but I'm not sure I have poor memory and forgot it.
It happens.
Okay.